Welcome back. We are moving into a new concept. We're going to be talking now about percent composition. So, what is that? So, these are the concepts we're going to discuss to get to the point. We're going to determine the mass percentage for a chemical formula. And we're going to use, once we determine that mass percent, we're going to use that as a conversion factor, which you're very familiar with, right? Looks like a fraction with a unit on top and an equivalent unit at the bottom, and we can flip it depending on what we're trying to eliminate. So let's begin that with this definition. What is mass percent composition? Let's do it first for a sample of a substance. Let's say, for example, that I have a substance that is like that, but this substance is composed of component A and component B. So you can say that the component A is about half of the total. So in other words, it's about 50%. Okay, let's see that in more chemical terms. Let's say, for example, that I have a sample of NaCl, which happens to weigh 25 grams. And then I do something to it that I break it into Na and Cl. And I have, in this particular case, I have about 18, let's say 16 grams of this and 9 grams of that. So we can say then that for every 25 grams of the compound, I'm gonna have 9 grams of sodium. We can also say that for every 25 grams of the compound, I have 16 grams of chlorine. Once I do that division and I multiply by 100, excuse me, that's gonna give me the percent mass of chlorine in NaCl, and the same thing will apply to the sodium. So that's how we do percentage for a substance. How do we do percentage for an element in a compound? And we have done this before. We did this when we talk about constant composition back on chapter 5. So if I happen to have water, which I know I have a molar mass of 18.0 grams from the periodic table, and it contains 2 hydrogens and 1 oxygen, and the hydrogens are 1.0 grams per mole, so I have a total of 2.0 grams per mole of hydrogen, and the oxygen is 16.0 grams per mole. So I can say that out of every 18 grams, which is what the water is, I have 2.0 grams of hydrogen, which is what the hydrogen is, which is the hydrogen we have in there. I can also say that from every 18 grams of water, I have 16.0 grams of oxygen. And if you multiply that by 100, that gives you the percent of oxygen in water. If I multiply this by 100, that gives me the percent of hydrogen in water. So that's how we do it with the formula. That's how we do it with a given amount of a given substance. So let's do some problems with that so we can get a better idea of how to use these concepts. Before we go there, so how can percent composition be used as a conversion factor? So let's say that I tell you that I bought a ring, and that ring have 30% gold. So how can I even use that as a fraction if I told you that a fraction is like a fraction, like a conversion factor is like a fraction? So you just translate it. If you have something that is a percentage, it's always going to be out of 100. So I told you that the ring is the one that contains 30% of gold. And you can be talking about mass, you can be talking about volume, but the unit has to be the same. So given a percentage, any percentage that I'm given, always write it over 100 and then put the number on top. And depending on what the problem tells you, if you're dealing with mass, it could be grams, it could be kilograms on both of them. As long as they're always the same, top and bottom, you're good. You just try to put whatever unit you need for the problem you need. So that's how we take a percent composition and made it into a conversion factor. So let's go ahead and use that. So a problem like this, if you have 1.912 grams sample of calcium chloride, so immediately you have to be saying, oh, calcium chloride. I know how to do that formula. I know calcium is +2, chloride is -1, crisscross, CaCl2. And you know the reason behind it. So we have a 1.912 grams sample of that. Is decomposed, basically broken apart into its constituent elements, which are going to be calcium and chlorine. And calcium, you come up with 0.690 grams after you weigh it. And chlorine, you come up with 1.22 grams. And we want to calculate the mass percentage for calcium and for chlorine. So once more, we got 0.69 grams of calcium out of 1.912 grams of calcium chloride. That was given right there, right? If you multiply that by 100, you get the percent of calcium. What about the chlorine? Where chlorine we have 1.222 grams of chlorine out of the whole compound, which is 1.912 grams of calcium chloride. You multiply that by 100, and you're going to get the percentage of chlorine in this compound of calcium chloride. So that's what you do. If you understand how to do percentages, this is the same thing. You know the total, you know the item of interest divided by the total times 100 gives you a percent. And that's just the mathematical definition. So let's do this one. Copper 2 fluoride. So copper, which is 2 plus because it's telling us so. And fluoride, which is on group 17, therefore -1, crisscross. So we're talking about copper 2 fluoride, that there. And what is it telling us to do? It contains 37.42% of fluorine by the total mass. Use this percentage to calculate the mass of fluorine. So we're looking for the mass of fluorine in grams contained in this much copper 2 chloride. Basically, given 28.5 grams of copper 2 chloride, can you find the grams of fluoride? I said fluoride and I wrote down chloride, sorry. So, fluoride. So, So obviously, I set up a train track or a dimensional analysis, so I'm gonna need a conversion factor. Where do I get my conversion factor? Well, we just talked about that, right? We just talked about how to take a percentage and make it into a conversion factor. So we're gonna take the percentage, which is 37.42% for fluoride, and we're gonna say, oh, this is a percentage. So immediately over 100 of the compound, calcium fluoride, and we have 37.42 of the fluoride. And given that we're trying to find the mass, we're just gonna conveniently put mass units for both of them. And then we go back to what we know. We don't care about the grams of copper fluoride, so we're gonna put grams of copper fluoride, copper 2 fluoride at the bottom because we care for the mass of the fluoride. Remember that I told you about 2 lectures ago? It's super important that you label all of these because very soon the units are gonna be the same. So we're dealing with grams and with grams, so you definitely need to know which one you're referring to. And then we know that I don't know what's wrong with me today. Copper, not calcium. Sorry. So now we're just gonna put that where it goes. So the compound gets the 100. That's just from here, right? And the fluoride on this case is 37.42. So that cancels, and that will give us the grams. So you're gonna multiply 28.5 times 37.42 divided by 100. So all we did, we took the percentage and made it into a conversion factor and use it. So we use it right here. So here's your daily work. So you're basically doing the same thing I did, but doing it with a different compound. What I did within the last 2 slides. And once you're done with that, then you can do that one. And let me re-emphasize, remember, you're doing the daily work. So if all you give me is the answers, I cannot give you any assistance because I am not seeing if you are doing something wrong. I am not checking the answers. I'm looking for the process. So that's how I can help you, if I can see what you're doing and correct you somehow. Daily works, the grade is completion, so as long as you do all of them, you get 100%. But I leave you notes to help you say, hey, go review this. You did it, but it's wrong. So it doesn't affect your grade, but it definitely affects your knowledge, and it will definitely affect you when it shows on the test later. So make sure that you always show your work. So after you're done with this one, go ahead and do this one. And once you do that one also. So now you have all the knowledge you need to develop more practice by doing this. And once you do that, we are basically done with these 2 objectives. So given the mass percentage, and be given a formula, can you determine the mass percentage? And once you determine the mass percentage, can you use it as a conversion factor like we just did? So this obviously requires practice, so go practice more. If you notice, some of the problems I've been taking them out of the textbook, so to keep consistency, so you can go back to the book and review them if you need to. And with that, next time we meet, we're gonna finish this chapter where we're gonna be doing empirical formulas. So until the next one, see you later. Take care. Let me know if you have any problems, email me or go to the Q&A board.